X-Linked Retinitis Pigmentosa, XLRP, is a genetic disorder that primarily affects the retina, the light-sensitive layer at the back of the eye. It is one of the many forms of retinitis pigmentosa, RP, a group of inherited eye conditions that lead to progressive vision loss. Here's an overview. Key characteristics. 1. Inheritance. XLRP is inherited in an X-linked manner, meaning the gene causing the condition is located on the X chromosome. 1. Males, who have only one X chromosome, are usually more severely affected, while females, who have two X chromosomes, can be carriers and may exhibit milder symptoms or remain asymptomatic. Symptoms: night blindness, nyctalopia, is often one of the earliest symptoms. Peripheral vision loss, leading to tunnel vision. Gradual loss of central vision over time. Difficulty adjusting to changes in lighting. 3. Progression. The condition often progresses more rapidly in males than in females, leading to significant vision impairment or blindness in adulthood. Causes. XLRP is caused by mutations in genes associated with the function and maintenance of the retina. Most commonly: 1. RPGR, retinitis pigmentosa GT pace regulator, the most frequently implicated gene in XLRP. 2. RP2, retinitis pigmentosa 2, another gene linked to the condition, though less commonly. Diagnosis. 1. Genetic testing confirms the presence of mutations in the associated genes. 2. Electroretinography, ERG, measures retinal function and is often used to assess the severity. 3. Ophthalmic imaging like optical coherence tomography, OCT, and fundus photography can help evaluate retinal damage. 4. Family history analysis helps identify inheritance patterns. Management. While there is currently no cure for XLRP, management focuses on preserving vision and slowing progression. 1. Low vision aids, tools like magnifiers and specialized glasses. 2. Vitamin A supplementation, sometimes recommended under medical supervision, though its benefits are debated. 3. Emerging therapies. Gene therapy. Trials are ongoing for treatments targeting RPGR mutations. Retinal implants and stem cell therapies are experimental but promising. 4. Support services, vision rehabilitation and counseling. Effects on the retina. 1. Photoreceptor degeneration. Rod cells. These cells, responsible for night vision and peripheral vision, are usually affected first. Their degeneration leads to early symptoms such as night blindness and difficulty seeing in low light conditions. Cone cells. Over time, cone cells, which provide central vision and color perception, are also damaged. This results in central vision loss and reduced ability to distinguish colors. 2. Structural changes. Pigmentary deposits. As the disease progresses, clumps of pigment, often described as bone spicules, accumulate in the retina. These are visible during an eye exam and are a hallmark of retinitis pigmentosa. Thinning of the retina. The loss of photoreceptor cells and supportive structures causes the retina to thin, particularly in the peripheral areas. Optic disc pallor. The optic disc, where the optic nerve connects to the retina, may appear pale due to degeneration and reduced signal transmission to the brain. Narrowing of retinal blood vessels. This is another common finding in advanced disease stages. 3. Macular involvement. Although the macula, central part of the retina, is initially spared, it eventually becomes affected in advanced stages. Cystoid macular edema, swelling in the macula, is a common complication, potentially causing blurred central vision. Vision loss in XLRP. 1. Stages of vision loss. Night blindness. This is often the earliest symptom due to rod photoreceptor degeneration. In peripheral vision loss. Progresses gradually, leading to tunnel vision as the disease worsens. Central vision loss. Occurs later in the disease when cone cells in the macula are damaged. Severe visual impairment or blindness. In advanced stages, both central and peripheral vision may be nearly or completely lost. 2. Progression. XLRP generally progresses more rapidly than other forms of retinitis pigmentosa, particularly in males due to their single X chromosome. Vision loss often starts in childhood or adolescence and worsens into adulthood, with many affected males experiencing significant vision impairment by their 40s or 50s. 3. Impact on color vision. As cone cells in the central retina are affected, color perception becomes impaired, particularly in the advanced stages. Functional impact. 1. Difficulty seeing in dim light or darkness, night blindness. 2. Challenges with spatial navigation, particularly in unfamiliar or low-light environments. 3. Reduced ability to detect motion and objects in peripheral areas of vision. 4. Difficulty reading or recognizing faces as central vision declines. Why the retina is affected in XLRP. 1. The genes associated with XLRP, such as RPGR and RP2, are critical for maintaining the structure and function of photoreceptor cells. 2. Mutations in these genes disrupt protein production or function, leading to photoreceptor cell death through processes like oxidative stress, inflammation, or impaired waste removal. Types of retinitis pigmentosa. 1. Classification by inheritance pattern. Inheritance patterns determine how the disease is passed down in families. The main types are 1. Autosomal dominant RP, ADRP, accounts for about 15 to 25% of cases. Inherited from one affected parent. Mutation in one copy of the gene is sufficient to cause the disease. Tends to have a slower progression and milder symptoms. 2. Autosomal recessive RP, ARRP, represents 50 to 60% of cases. Both copies of a gene, one from each parent, must have mutations for the disease to manifest, and typically more severe and starts earlier than ADRP. 3. X-Linked RP, XLRP, accounts for 5 to 15% of cases, caused by mutations in genes located on the X chromosome, e.g. RPGR, RP2. Primarily affects males severely, while females may be carriers or exhibit mild symptoms. Progresses more rapidly than other forms. 4. Mitochondrial RP, rare form associated with mutations in mitochondrial DNA. May often occurs with other systemic or syndromic conditions. 2. Syndromic versus non-syndromic RP. Non-syndromic RP. Vision loss is the only significant symptom. The most common form. 2. Syndromic RP involves other systemic symptoms in addition to vision loss. Examples include Usher syndrome, RP combined with hearing loss. Bardet-Biedl syndrome, RP with obesity, kidney abnormalities, extra fingers or toes, and cognitive impairment. Refsum disease, RP with peripheral neuropathy, hearing loss, and other systemic issues. 3. Classification by gene mutations. Over 100 genes have been identified as causing RP. Some of the most common include 1. RHO, rhodopsin, frequently associated with ADRP. 2. USH2A, causes both non-syndromic RP and Usher syndrome type 2. 3. RPGR, the most common gene mutation for XLRP. Or EYS, eyes shut homolog, a leading cause of ARRP. 4. Early onset versus late onset RP. 1. Early onset RP. Symptoms appear in childhood or adolescence. Tends to progress more rapidly. 2. Late onset RP. Symptoms start in adulthood, typically with slower progression. 5. Atypical variants. Some forms of RP present with unique patterns or progression. 1. Sector RP. Degeneration is limited to specific sectors of the retina, often with milder symptoms. 2. Paracentral RP. Involves the mid-peripheral retina first, sparing the central and far peripheral retina until late stages. 3. Inverse RP. Central vision is lost earlier, with peripheral vision remaining intact longer. Summary. 1. RP is not a single condition but a spectrum of disorders with over 100 genetic causes. 2. It is broadly classified by inheritance patterns: autosomal dominant, autosomal recessive, X-linked, mitochondrial, syndromic associations, and specific gene mutations. 3. The diversity of RP reflects the complexity of retinal function and the many genes involved in maintaining photoreceptor health. These are just some examples when it comes to the spectrum of RP and the many different eye issues out there. This video was created to help spread some awareness and helpful information. As someone who has XLRP, I thought this would be a good way to help explain a bit about my own eye disease and share a bit of info on other types of RP and the issues our community deals with for vision impairment.